Hi, this is Mrs. Holbrook with our basic STEM review continuing in geometry. We're moving back to chapter 4 right now on congruent triangles. We're going to work on these first 6 lessons of this chapter. So classifying triangles, angles of triangles, congruent triangles, proving if the triangles are congruent by side, 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 angle, side, angle, and angle, angle, side, and dealing with isosceles triangles. Alright, some main ideas in this unit, this lesson 4.1. Identify and classify triangles by angles. Identify and classify by the sides. Here are the words that we need to think of. For angles, we have acute triangle, so all of the angles are less than 90, but more than 0. Obtuse triangle, one angle is greater than 90. A right triangle, one angle is 90. And an equiangular triangle, all 3 angles are 60 degrees. A scalene triangle where no sides are congruent, an isosceles triangle where 2 sides are congruent, and an equilateral triangle where all 3 sides are congruent. Okay, and here are the official definitions and an example of each that I was just going over. For acute, all 3 are less than 90. Obtuse, 1 is more than 90, and right, 1 is exactly 90. So here's a real-world example. This truss below is modeled for steel construction. Use a protractor to classify those 3 triangles as acute, equiangular, obtuse, or right. Most of the time we don't even need a protractor to do this. So triangle JMN, JMN, so we're looking at the great big triangle. Right here I can see that this angle is pretty wide. It's an obtuse angle, so it's an obtuse triangle. JKO is right here. And again, I'm pretty sure, I can't know for a fact without getting a protractor, but I'm pretty sure that looks like a corner of a piece of paper, which makes that 90 degrees, which would make that a right triangle. And OLN, all 3 of these angles here look about the same. So I'm going to say that that is probably an equiangular triangle. And if we check our answer, JMN has 1 measure greater than 90, so it's obtuse, which is what we said. JKO has 1 measure equal to 90, so it is a right triangle, which is what we guessed. OLN is an acute triangle with all angles congruent, so it is an equiangular triangle. So we were right without even using a protractor. Alright, let's see if it'll let me... That was there from before. Okay, so in your notes, here's the first practice problem you need to do. Please put this drawing in there so you know what you're talking about later on. And for number 1, there's an A, B, and C. So for 1A, you need to classify triangle ABC. So A, B, C. So do you think it's acute, equiangular, obtuse, or right? Take a second and make your decision. Okay, here's 1B. The problem has stayed the same, the drawing has stayed the same, but now we're looking at triangle ACD. Look, I circled better this time. ACD. Again, is it acute, equiangular, obtuse, or right? And please write the word, you guys. Don't just write what letter choice you're making. And here is 1C. This time we're looking at triangle ADE. ADE. And decide, is that triangle acute, equiangular, obtuse, or right? And this is the last part of question number 1. Okay, the next idea is classifying triangles by the sides. Again, a scalene triangle, none of the sides are congruent. Isosceles, 2 sides of the triangle are congruent, and equilateral, all 3 sides are congruent. So classify triangles by the sides. In this crazy looking picture, they want us to decide which triangles are the isosceles triangles. If UV, where's my V? UV, so this long piece here, is congruent to VX, which is congruent to UX. Okay, so we know that we have an equilateral triangle here at least because all 3 of those pieces are the same. And they've also given us these 2 marks. So isosceles. I know that if this side is congruent to this side, this is an isosceles triangle, UTX. And even though we said all three of these pieces are congruent, since at least two of them are, we can also say it's isosceles, U, V, X. So if we continue moving on, it tells us two sides are congruent. So UTX using these little congruent marks that they gave us here, and UVX using the information right up here. Make them both isosceles triangles. Now they want us to identify the scalene triangles in this same drawing. Okay, so there's a lot of them, so it's best to just kind of pick a point and start looking at the triangles. Alright, so we know VUX is equilateral. What about VYX? We don't have any two congruent sides, so that's scaling. What about VXW? Well, that looks like it might be isosceles, but nothing is marked, so we have to call it isosceles for now. What about VUZ? Again, I have a mark here, but I don't have the other side, so VUZ is also scalene, which means VXY is probably scalene as well. What about these cute little triangles here? These YTU and ZTX. Okay, I don't know if I missed any, but there are certainly a lot there to look at. So you can look and see if we missed any. I don't remember how many I named there, but quite a few. Okay, now on your own, you need to determine which two triangles are isosceles. So go through the list, compare one triangle to the next, and remember you're looking for two triangles where two sides are marked the same. Please make sure you include this drawing in your notes because I think that there are 2 or 3 parts to this question. Number 2B, again, same drawing. Now they want to know which one of these 4 triangles is scalene, so none of the sides are congruent. Okay, we're done with question number 2. Now we're throwing our algebra in. Here we have an equilateral triangle, and they need us to find D and the measure of each side of that triangle. Okay, they have each piece labeled. Since we know that it's equilateral, we can pick any 2 sides and set them equal to each other to solve this problem. So they went with KL and KM. So D plus 2 equals 4D minus 13. Subtract D from each side. Add 13 to each side, and D is 5. So then you just substitute it back in for the 3 sides, and we will find out again it was equilateral, so all 3 sides better come out to 7, and they do. Alright, here's one for you to try again. It is an equilateral triangle, so all 3 sides are the same. So pick any 2, set them to equal to each other, and then find out how long each side is. Okay, now we're getting into the distance formula, and this is something new to this class. I'm pretty sure we haven't done it this year. Usually in geometry we've done this several times by now. So the distance formula is D equals, D for distance, the square root of x2 minus x1 squared plus y2 minus y1 squared. And remember, every point on a coordinate grid is x comma y. So when we find side RS, we're going to use this point at -1, -3 and s at 4, 4. Then you would need to find side ST using 4, 4 and 8, -1. And then you'd have to do the distance formula a third time to find the length of RT using -1, 3 and 8, -1. So please make sure you get this distance formula written down in your notes so that you can use it. So continuing with their example, RS, they plug in the points. Again, x2 minus x1 plus y2 minus y1, both of those squared. So the length of RS is the square root of 74. The distance of ST is the square root of 41. And the distance of RT is the square root of 85. So all 3 of these are different, making it a scalene triangle. Here is your last problem to try today. Okay, again, distance formula, I'll write it up here. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and remember every single point, like right here at B, is x comma y, so the point at B is 4, 5. Now you probably don't really need to do the distance formula for side AB, you can just count the distance. But you will need to use the distance formula for side BC and for side AC. Okay, so don't just write down A, B, C, or D. I want to see the distance formula work, making your decision for what type of triangle it is. Okay, I will see you in class.